The James Webb Space Telescope has discovered something truly extraordinary, beams of light that look like they are radiating from a city center. This discovery, located light years away, has reignited interest in the potential existence of extraterrestrial life. The telescope directed its focus toward Proxima Centauri and the closest exoplanet, Proxima Centauri b, in our solar system and noticed strange, brilliant flashes of light. Could these signals be signs of an alien civilization? Stay tuned for more. Advancements made over the years by both scientists and everyday people have been fascinated with the idea that there is life beyond Earth. Any indication of the presence of space exploration has been met with great enthusiasm. But a pivotal moment came when the James Webb Space Telescope presented clear evidence suggesting the existence of life somewhere in the cosmos. While scanning the depths of space, this powerful telescope discovered something extraordinary on an exoplanet. Because it was so far away, it detected lights resembling those from extraterrestrial cities, raising the possibility that an alien metropolis might exist on that distant planet. This idea has generated significant excitement and curiosity within the scientific community, as it could be the breakthrough they have long anticipated. It hints at the presence of intelligent beings operating civilizations in ways we are only beginning to investigate. These city-like lights, observed from a remarkable distance of 4 light-years away, have left NASA engineers astonished, wondering just how long they might have been visible in space, waiting for our technology to advance to the point where we could detect them. David Kipping, an astronomer at Columbia University, has described the planet where these lights were, found as especially intricate. Unlike most rocky planets that absorb sunlight and emit energy as infrared radiation, this exoplanet behaves differently due to its unique relationship with Proxima Centauri, its host star. This is what the James Webb Space Telescope discovered. The telescope's crucial function and capacity to capture infrared wavelengths were essential in identifying the unusual behavior of Proxima Centauri b, which is vital for comprehending the planet's atmospheric conditions. Researchers are planning to continue using the telescope to study the atmosphere of this planet in more detail, with hopes of investigating the possibility of habitability. The James Webb Space Telescope's high sensitivity to infrared light allows it to see what happens on Proxima Centauri b, even during the night. Many telescopes struggle to detect faint light in the vast darkness of space, but the Webb telescope excels at picking up even the faintest glimmers. This makes it an excellent tool for confirmation. If the alleged city lights on the dark side of Proxima Centauri b are indeed real, the telescope can detect artificial light in space as long as it fits within a very specific frequency range, which is much smaller than the light emitted by regular stars. Proxima Centauri b's interaction with its star heavily influences its environment. Like many planets that orbit stars, it captures intense energy from Proxima Centauri. As the planet revolves around the star, it goes through cycles of day and night, much like Earth. The planet experiences scorching heat during the day and cooler nighttime temperatures. There are a variety of temperatures on Proxima Centauri b, primarily due to its composition. For example, if the planet has an atmosphere, the temperature difference between day and night would be extremely hot on one side and frigid on the other. This dramatic thermal fluctuation is a key area of interest for astronomers, as it provides valuable clues about Proxima Centauri b's atmospheric makeup. The James Webb Space Telescope, with its ability to image in the infrared spectrum, is able to examine the global emissions of heat, offering insights into its atmospheric properties. Interestingly, the orbit of the James Webb Space Telescope around Earth coincides with the orbital period of Proxima Centauri b, enabling scientists to make detailed observations of its day-night cycles every 11.2 Earth days. If Proxima Centauri b has an atmosphere, the next step will be to analyze its chemical makeup to find out if it could facilitate life. Detection of components like methane, water vapor, or oxygen would suggest the planet's potential to harbor life. This would involve studying the light passing through the planet's atmosphere, a complex process. While the James Webb Space Telescope is excellent for characterizing planetary atmospheres, it is primarily designed for other tasks. Its expertise lies in analyzing the concentrations of water vapor, carbon dioxide, and methane, but it is less adept at detecting free oxygen, an important indicator of life. Nonetheless, the telescope can search for other key indicators, like ozone, which signals a healthy atmosphere. As scientists examine the data gathered from the James Webb Space Telescope, the search for distant worlds continues. We are getting closer to answering the question of whether we are alone in the universe. It is essential to note that the James Webb Space Telescope can only observe a certain number of exoplanets closest to Earth. For more in-depth examinations of planetary atmospheres, astronomers will rely on ground-based observatories like the Extremely Large Telescope, ELT, which is set to begin operations in 2028. The ELT is designed to offer a deeper look at the atmospheric structures of exoplanets far away, providing clearer and more in-depth information about their capacity to support life. Scientists are eagerly awaiting the launch of future space telescopes like the ELT. In the meantime, the James Webb Space Telescope remains an invaluable tool for exploring distant exoplanets. Despite its limitations, the Webb Telescope continues to offer critical information that may change our comprehension of what lies beyond our solar system. Researchers have ambitious plans for future space telescopes. They aim to develop technologies that reduce interference from starlight, allowing for better observation of the surrounding planets. This is similar to blocking the sun with your hand so that you can see more clearly. The capability of these forthcoming telescopes to concentrate on the dim light reflected by exoplanets makes it easier to analyze their atmospheres and assess whether they might be capable of supporting life. However, this task is far from simple. Stars are incredibly bright, often vastly outshining the planets around them. This brightness makes it difficult to detect the faint light that planets reflect, which is essential for studying their characteristics. To address this challenge, scientists are working on several novel strategies, one of which involves the use of coronagraphs. These devices are placed inside telescopes to block out starlight while letting the light from the planet pass through. By carefully shaping the light waves, coronagraphs can significantly diminish the star's brightness, making it easier to detect the dim light from exoplanets. Another promising approach is the Starshade, a massive flower-shaped spacecraft that flies in formation with a telescope, further enhancing the ability to observe faint planetary light. Positioned tens of thousands of kilometers away from the telescope, the Starshade blocks starlight before it even enters the telescope, allowing only the light from exoplanets to reach the instruments. This method might be particularly effective in observing planets within the habitable zone of their stars, where liquid water could exist. It's possible that life exists, but these advanced technologies require exceptional precision. For instance, the alignment of a star shade must be perfect to millimeter-level precision over vast distances. Moreover, these innovations need to overcome the limitations posed by space missions, including the need for miniaturization, energy efficiency, and the ability to withstand the harsh space environment. Despite these obstacles, the potential benefits are enormously positive. Observing and evaluating the environments of exoplanets may result in the discovery of chemical signatures or biosignatures of life, such as oxygen, methane, or water vapor in specific ratios. These molecules might point to biological processes, suggesting that researchers believe life exists beyond Earth. Scientists are also exploring ways to directly image distant worlds in greater detail. Future telescopes could be equipped with advanced adaptive optics, which adjust for distortions caused by Earth's atmosphere or the telescope's movements, resulting in sharper combined images. With starlight blocking technologies, these improvements could allow scientists not only to detect exoplanets, but also to map their surfaces and study their climates. The development of next-generation space telescopes represents a significant leap forward in our quest to answer one of humanity's most profound questions. Are we alone in the universe? By enhancing our ability to observe these far-off planets, we are coming closer to finding out if life exists beyond Earth, potentially transforming our understanding of our place in the cosmos. The future of space exploration and the search for life elsewhere are advancing at a rate never before seen as scientists and astronomers dive deeper into the enigmatic worlds of faraway exoplanets. The James Webb Space Telescope is opening a new era of cosmic discovery. The data it gathers is helping astronomers uncover groundbreaking information regarding the structure, composition, and potential habitability of far-off worlds. With each new piece of information, we edge closer to answering the fundamental inquiry: is there life beyond our planet? Proxima Centauri b's discovery is just the beginning of what could become a major turning point in how we approach the study of extraterrestrial life. Proxima Centauri b, being the closest star to our own solar system, has been a focus of intense research for years. However, locating tangible evidence of life, such as artificial light or signs of civilization, was a dream for many scientists. The fact that such light has been detected by the Webb telescope only enhances the hope that one day we may communicate with other intelligent life in the universe. This kind of discovery fuels both scientific curiosity and public sentiment, sparking new ideas and inspiring generations to think beyond the confines of Earth. As the James Webb Space Telescope continues its observations, it's not only looking for artificial lights, but also focusing on planets' atmospheres, their chemical compositions, and how these factors might support life. The search for biosignatures, like methane or carbon dioxide in the right concentrations, is vital for determining whether these planets have the right conditions for life. The Webb telescope has the ability to analyze these atmospheric elements in a way that no other telescope has been able to, shedding light on the potential of distant worlds to support life similar to Earth's. One of Proxima Centauri b's strengths is its location within the habitable zone of its star, where the right conditions might exist for liquid water to form on its surface. The habitable zone is the region around a star where temperatures are just right, not too hot and not too cold, for liquid water to exist. This is regarded as a critical factor in determining whether a planet could harbor life. Water is essential for life as we know it, making the discovery of an exoplanet within a star's habitable zone an important target for future missions. In addition to finding life-supporting planets, future space telescopes will also focus on the complex relationship between exoplanets and their stars. Some planets, like Proxima Centauri b, are tidally locked, meaning one side always faces the star while the other remains in darkness. This can create extreme temperature differences between the two sides of the planet, which would affect the planet's climate and its potential to support life. Understanding these conditions is critical for astronomers as they assess the likelihood of habitable environments on exoplanets. The development of technologies that can block out starlight is another important advancement in space exploration. Without the ability to block out starlight, it would be virtually impossible to observe the faint glimmers of light from faraway planets. The starshade and coronagraph technologies mentioned earlier are prime examples of how scientists are overcoming these challenges. By blocking out the overwhelming brightness of a star, these telescopes can detect the faint light reflected by planets, which could reveal crucial details about their surfaces, climates, and potential for life. Another exciting development in this field is the concept of directly imaging exoplanets. With the aid of starlight-blocking technologies and advanced adaptive optics, astronomers hope to capture high-resolution images of planets as they orbit their stars. These images would not only provide more comprehensive data on the planet's composition and environment, but might also offer a closer look at surface features, such as oceans, continents, or weather patterns. This type of imaging would represent a giant leap in our ability to study exoplanets and make informed conclusions about their potential to support life. As we continue to explore the universe for answers about the existence of life beyond Earth, the role of the James Webb Space Telescope and future missions will be essential. The telescope's capabilities to detect faint signals from distant planets, analyze their atmospheres, and examine their potential for habitability are transforming our understanding of the cosmos. With advancements in technology and an ever-growing body of research, we are on the brink of making discoveries that could reshape our knowledge of life in the cosmos.